Today we will code question answering with the Graph database, where that dataset is available with Graph database, and we will be using as a in context learning, where that data is not available with LLM, and that data we need to provide as a private data to Graph database, and we use as a knowledge management, and with the question answering using LLM we will be getting required information from there. We might have worked a lot with the CSV data set or SQL data set, where that we did question answering earlier also. And Graph database is also very popular for that type of use case, where that we need dynamic type of information, like we have a recommendation engine, where we have social network type of information, or complex dynamic type of relationship we need it, like as a node and edges type of thing. So for that I'm using here Neo4j Graph database. We will see from the scratch like how to install Neo4j. And apart from that, I am using Gemini Pro free version of large language model provided by Google. And as I told earlier, like I'll be using Neo4j Graph database for this particular task. To install Neo4j, you need to visit Neo4j installation site. Like I'm here right now. You can download it here. While downloading, it will be asking certain details. Just give it information here and download it. After installation, just copy this to activation key to your clipboard. It is required because we will be using this one to activate our Neo4j. So it's downloaded at particular location. I'll be opening this one and starting. So starting installation. Let us give it next. Install. Just give the location. I'm just keeping all this thing default. So it is completed right now. I'll be running it. Just finish. So when it started, you will see this welcome screen. Just agree with the license. Just see where you need to save your all this like database file. So I'm just keeping everything default. Now you can provide your details here. Just keeping things default. And what we copied software key that time from here, just paste it here and activate. Now we can see this setup is completed. I'll just not update right now and I'll do OK. So this one example project is already given movie DBMS. Like if you can click it here, it is already started. You can click it here, Neo4j default, and you can see there are already some relationships are there, and some properties edges are there. We can see it in the windows also. Like I'll just open that one. So first we'll just see a few important steps. The first is like open, just click this movie DBMS and just see plugin here and epoch. By default it is not installed at that first installation. You need to install it, because if you will not do it, it will throw error when you are going to run your code in the project. So we'll install and restart that database. We can see right now it is installed and system is started, like database is started. We need to change default password. We'll come here, details, and reset DBMS password. We'll give some password. I'm just giving it some random password. We can see password reset is completed. So with this, our database is ready with us, and we can start working on our task. So right now I can see it here. There are 169 nodes and there are 250 relationship, and we can go and just check that also. Let it open. So you can come from here, just click this as a open, and you will be directed to some other window where you can check everything whatever is there in database. So when we click it, like if you see it, you are connected to user Neo4j, and like I am here as a Neo4j default user. I am not changing any user, just only changed the password right now, and open this data set and click this one. Now you can see like all the graphs and multiple information. You can see here movie and person. There are two nodes. Movie is like all the movie information, and person is just another node, and blue is, if you can see, movie, and person is like another node, and we have it like connected through edge. So if you see it here, some different movie name is there, and how they are connected through other node like person, with that your edges is like you have edge, and that has property acted in like this one. So we will use this particular data set for our task right now. Next task is to create Google API like Gemini Pro API key, and you can come to this particular console cloud google.com, where that you can click credential, and with the credential create credential API key, you can create API key that can be used as a like a key for your Gemini Pro. So let us start coding part. Before starting, we will create virtual environment, and in that we will install all those library needed for us. For installing virtual environment, we need Python -m when dot. I'm just creating the name virtual environment. You can see it is created here. Let it come here, and after that activate this one. So I'm just giving when dot when and tab, in that scripts activate. Basically you are coming here when and scripts, and in that activate is there, just activating it. Now you can see it here. So right now you are into black box. Right now you are into one container where you can install your libraries. Let us start creating files. So first is requirement .txt. So all these libraries needed: Langchain community, Langchain Google Gemini, since we are using Gemini Pro, Neo4j library supported for with the Langchain, Streamlit, and Python environment, since we are using environment file to keep all these keys there, like whatever we are using it as a Neo4j and Gemini Pro. So let us run that pip install. So by time it is installing, we'll go and do the other stuffs, like I'll create one environment file .env. So I created environment file. Environment file I kept Google API key. That's what I shown it here, like the show key, and copy it here. And after copying it, you can paste it here. And after pasting it, like your Google API key is ready here. Neo4j URL, you can come to here and just see 7687. That is by default. So it will be same key, like same URL, like it is bolt colon slash slash. Localhost is like we are using localhost right now. There is no API, IP here. 7687, like we are using bolt prefix, and then using not HTTP HTTPS. And note for Neo4j username is Neo4j, like default we are using Neo4j, and Neo4j password whatever you have given it. Like after resetting this password, you need to reset password, otherwise it will not take. By default it takes some other password. Just reset this one. Two thing, plugin and reset part, it is important for the other step. So we have this environment file ready. Now other part is important part, it creating utils.py. This is important part where that we are using all this code like backend code. So I copy pasted all the required code here, and if you see it, like we have important imports here, like one import OS is there, is the common OS task, and dot environment and load dot environment, like importing load dot environment. It is just to load all this environment variable whatever we added into environment dot environment file to this particular module. And we have Langchain library, basically Google Gemini Langchain library, where we are using chat Google generative AI, since we are using Gemini Pro. So for that chat Google generative AI, important thing here is Langchain community chains graph QA dot cipher, that is basically graph cipher QA chain. Since we are using graph database, and this is Neo4j graph database, Neo4j graph database has one query language. Basically it is having cipher graph query language that we use it in Neo4j, and for that Langchain has support that is having some question answering chain available to Langchain, and we'll be using that one, so that it will abstract everything. Like internally you just ask question, it will convert into cipher graph query language that your Neo4j will understand and give the answer based on that. And another one is your Neo4j graph. Since we are using Neo4j graph, it will be using Langchain library to create instance. And all this Google API key, Neo4j URI, everything we set it as environment variable in our local module right now in this utils.py, so that this is available os.get environment. It is available from here, and available as a module, as a like I can say system variable to your module. Now you don't need to assign it to explicitly assign it to anywhere. Anything what you're using it right now, later on it will be knowing it, like where it is all, where all these particular keys are there, like all these variables are there. So main file is your def main query, and basically def main function is your def main, and having as a parameter as a query. And query means like user asking question and it will be coming here, and then with that it will be getting, you will be getting answer. So if you see Neo4j Graph, Neo4j Graph is basically one class, and with the class is Langchain supported class, Langchain library class. And with this Neo4j Graph, it checks like Neo4j URI, username, password. It takes everything like whatever is there in your environment. It will take that all this variable, and with that it will initialize and create graph. And with the graph we'll be knowing it all schemas here. Like if you see it here, we have all this schema here right now. What all things, what we see it here, this all things will be available to right now our module using this particular particular graph variable using Neo4j Graph. And since we already given this all information here, with this it will connect and get the information. So we have a schema. Now we created instance of Google generative AI, like our Gemini Pro, and keeping everything default and not giving any temperature and max length, anything. You can experiment whatever you want to do it. And with that LLM instance is created, one variable is created. So we have graph and LLM. Now coming back to the important part of graph cipher QA chain, that is where that all action happens. Like it does support Neo4j type of cipher graph query language, like chaining everything. So when we just use from LLM and passing it schema here and our LLM here, and verbose true means like it will give every information as output here whatever we want right now. And when we get response from this chain dot invoke and query, passing query here from the question, we get the response here. So this is our main logic utils. Like it's very new and simple logic. You can make it complex whatever you want to do it, and but it is just like simple things. I'm just showing it like a capability of question answering on the graph. So this file is created. Now I'll go to the another file app.py. That will have all this like stream related code. For the sake of time, I just copy pasted all this code from my local system. So this is simple Streamlit code. It is nothing like an very simple code. Like you might have done multiple times the Streamlit part, just Streamlit import, and I'm using utils like whatever I am having it in right now. Util.py logging, simple logging it here, setting it like a page configuration, header, info, just hiding it some tabs in Streamlit UI, and one reply container and one question container. Okay, and in this container, if container is available, if question available to us, then you just you check it like if we are having it question text input and we have submit button, both click. If you see it here, if submit button and user input, then result, go to utils like our this particular main function by passing your argument here and getting it response from here, return it back to our UI. So let us start this one and run. I saved everything and Streamlit run. So we can see this interface is like very simple interface is ready to us. And since we have it all this information in data base right now, graph database as a movie data set, you can have any type of data set, you can create it the way you want it. Like right now I already having simple data set as a movie data set with the two node movie and person, and having is and properties of those things. And you can see it all those things here also, like you can check it here. It's like good thing, intuitive way also, like you can make it big and smaller. You can see what other connections are there. It's like good. I found it's very good. I'll fire one query. Who is this or it's very new example, like very simple example. You can make it more complex and it's like in context learning. And when you do in context learning, we are not doing any RAG type of stuff. Like it is not like retrieval augmented generation type of things. It is just like we are connecting to graph database using this graph cipher QA chain that is available at our I can say Langchain library, and passing it like graph schema and LLM. And when we are querying it, it is going there, converting your query into cipher graph language and cipher graph query and get the response back. So you can utilize it like RAG type of pattern also, like you can use embedding models, and you can use vector database to store node and other stuffs and do all those things what you want to do with the RAG. It is up to you to make it more meaningful information, meaningful project out of this graph database. But it's good.